Welcome, everyone. Thank you for attending our second seminar talk for this term, Winter 2021. And I will be happy to introduce our second speaker, Dr. Ahmed Alibage. Dr. Ahmed Alibage, he received his doctorate in technology management from ETM department last year. And he worked with Dr. Yatter in his in his PhD. He has a little bit background about his background. He has a mechanical engineering from Baghdad University or University of Baghdad, and he also has his master's in engineering industry management. So he is right now he's a postdoctoral fellow with our department, and he's continues working his research with Dr. Yatter. With that, I'm gonna let Ahmed start presenting his presentation. So welcome, Ahmed.
Thank you so much, Maulud, for introducing me. Good afternoon, everyone, and thank you for attending this presentation entitled Achieving High Reliability Organization Using Fuzzy Cognitive Maps, the case of the offshore oil and gas industry. It's really a great honor for me to be talking through the ETM Distinguished Speaker Series. So I will start with talking about what is the motive behind, behind this research. The motivation is the persistently high accident rates in the offshore oil and gas industry. Probably some of the people know that working on an oil rig is considered as the most dangerous jobs in the United States or maybe even the entire world, because this kind of industry have left a really large number of disabilities, fatalities, and a lot of problems. Accident can have really large scale consequences. And a prevalent example is the British Petroleum Deepwater Horizon in 2010, which really caused 11 fatalities, 17 severe injuries, massive environmental damage, and even a hit to the government budget. And over that, it's caused the taxable income of British Petroleum by around $65 billion. These kind of consequences supposed to be a really strong incentives for organizations in the offshore oil and gas to strengthen their safety and safety culture to avoid all these kind of consequences. But obviously that current effort do not yield result or good result for many reasons. Some of these reasons, not all of them, but some of them could be the operation, because they are really very complex technical systems with many players. There are operators, owners, and contractor, and many other parties involved in the operations. The operation generally take out, or it happens, or in very trying conditions, marine environmental conditions, and there is a specific unique safety culture in this industry that value toughness and can-do culture. Also, the focus on accident is based on prevention and accident causation and aftermath and reporting. So it's not really by a system model that can actually tell you what is the problem, where is the problem. And also there is a limited knowledge about how to improve safety through safety culture, or what is called, or what is known as a safety culture. So a solution for this problem is based on a general agreement that offshore companies should learn from other industries or other organizations that have better safety records, and also share knowledge among themselves to leverage safety. This is a quote from the National Academy's report on 2016. That it says the nuclear power and airline industries provide helpful role models for many other industries and have exhibited a notable willingness to share information, both within their own and within our industries. The knowledge transfer is supposed to occur from a particular type of organization, namely the so-called high reliability organization, which I will mention and define throughout this talk. So to present this, I have an objective, which is for the long term, based on this research, to help the offshore oil and gas industry improve their safety based on a novel planning, decision support, and training tool. And here in this research, to create a system model of the principle of high reliability organization that's represented as a fuzzy cognitive map, and it's contextualized to the specific operational setting of the offshore oil and gas, and that can be used to simulate the impact of planned safety intervention. So throughout this presentation, I'm going to report on the progress towards achieving these objectives through the following agenda. I will first talk about the foundation of my work, namely what HRO are and what we know about them so far and their successful practices. I will also discuss how modeling can help transfer knowledge from the HROs to other organizations, and I will outline or pose and open questions, and I will then organize my talk around 4 critical activities that part of my approach, namely the building of FCM through the research text, contextualize the FCM model for specific offshore oil and gas, and gaining insights through simulating the model that I developed, and dealing with uncertainties using a method called Exploratory Modelling and Analysis, and then I will summarize the result in my discussion and conclusion. So as a foundation for my research, as I mentioned before, my work aimed to model the practice of high reliability organization and transfer the knowledge from them to the offshore oil and gas. HRO have enjoyed a record of high safety over a long period of time. And this reliable performance happened despite that these organizations are technologically sophisticated, their system elements are complex and tightly coupled, their operation happen under trying condition, they are socially and politically challenging, and their, again, system elements are interdependent and timely pressure. The operation are uncertain and hazardous, that problem could happen anytime. An example for this organization, the aircraft carrier, air traffic control operations, and nuclear power plants. HRO research investigate the commonalities and the practices of all these different industries. So all the HROs, high reliability organizations, share 5 principles that characterize their safety practices, namely the preoccupation with failure, the reluctance to simplify, sensitivity to operation, commitment to resilience, and deference to expertise. Each of these principles actually was identified through extensive qualitative research, and they are clearly defined. For example, preoccupation with failure is defined as a chronic precaution that motivate a proactive and preventive examination of potential weaknesses and treat any failure or near miss as an indicator for potentially large-scale accident or issue. So this is actually going through the literature about high reliability organization, make a big or post open questions. Despite being really researched and widely accepted theory, high reliability organization research currently cannot answer all the questions, or let's say several questions. First, it's unclear if all the 5 principles that I just mentioned in the previous slide are equally important. The literature assumes that they are equally important, but they have never been systematically approached or explored. Maybe it would be possible for the offshore and gas industry to practice few of these principles, but we don't know which ones. Another thing that we currently do not know if all the principles can be improved concurrently, at the same time altogether, as the literature assumes. It is possible that we can get really good in one principle, but we can find other principles suffering. For example, one of the principles is deference to expertise, which means that top management migrate or give an authorization to migrate the decision-making process to the people in front lines and empower them because they are expert and well enough, they are experienced, they have the experience to know the problems and how to solve the problems. But this type of migrating the decision-making to those people would make people on the other level on the operation floor to be less vigilant because they will rely on them and they will reduce their sensitivity to operation, which is another HRO principle. To explore these type of questions, my research developed a system model from the research literature. It can be used to try out what happened if question under different condition. In the context of system model, this trying out or if question, we call it assimilation or scenario planning. HRO research identifies a series of actions, such as specific training or protocols that are intended to improve the 5 HRO principle. However, because there is no HRO on the offshore oil and gas, we don't really know if the same intervention also work in oil and gas. One solution is to adapt the outcome of my research, which is this developed model, so that it reflects specific industry context in the offshore oil and gas. In my work, I do this with the help of industry expert. I call this process as a contextualization because the model that I developed is general based on HRO. And in order to investigate a specific industrial operational setting, I need to contextualize the model to their specific operational setting. The result is the model with a 2-layer. As you can see here, it's the core model, which is based on the research. The core model consists of an outer layer, which is representing the driver concept of the model. And here, representing the expert or the user defined, that they are going to feed the model through their intervention, through their opinion, to see how their opinion will impact the 5 principle. And this is the outer layer. In the simulation process, both these layers will be used. So, but I will first want to report and to talk about what do I mean by fuzzy cognitive map, or what is the fuzzy cognitive map. FCM or fuzzy cognitive map is a technique for representing system as a network of concept and the causal connection among or between them. Concept can be freely defined. They are not necessarily to be quantified. Concept can be anything qualitative, such as satisfaction, freedom, well-being, attitude, action, and any other kind of qualitative concept. The figure on the left that you can see here, it's a simple causal network or causal diagram. Concept A causes concept B to decrease, and causes concept C to increase, and concept C causes concept B to decrease, and then concept B causes concept D to increase, and concept C causes concept D to increase. So this actually causal connection, if I'm showing you how it will activate each concept by others, but this causal connection also can be transferred into an adjacency matrix that can be used for mathematical computation. Algorithm developed for artificial neural network, then used to compute each concept in the FCM, change in response to activating a single concept or combination of concepts. For example, I could simulate how an increase in concept A will be resulting in an outcome of concept D. If concept A increased, it will transfer the signal into these concept B and C, and they will transfer their signal into concept D as well. Using this algorithm, and if I assume that concept A, for example, is an intervention and concept D is a HRO principle, through presentation of the outcome, I could actually get what concept B could be, what is the change or degree of change in concept B. Not just that, I will get an insight about both concept B and C. However, I built this FCM model using literature, documentation. We have about 30 years of research literature about HRO, and I used specific kind of documents. And this is a piece of document that talking about HRO. It says, you can say here in bold gray that these are the concept. For example, success, Neuros perception. I interpret Neuros as a negative or decreasing causality. So you can see here, success is actually decreasing perception. It decreases opposing point of view. It breeds or increasing confidence. This is how I really came into the lens of causality to build this model. However, In FCM, causal connection are weighted in the interval between 0 and 1. One interpreted as a very strong to maximum strength between the concept, and 0 interpreted or referred to a very weak, or there is no really relationship between them. Assigning this weight is an important for being able to run simulation. However, the example here you can see show that research texts do not contain explicit information about how strongly success would decrease perceptions. I know that success reduced perception, but I don't know for how much. And the solution in the literature are to simulate unweighted FCM, which does not allow for fine-grained analysis. Another method is to survey experts to tell me what is the strength between success and perception, how much this success will reduce perception. But both did not work for my research. So that I came to a solution, which is I used a newly published research called thematic coefficient. And this novel approach allowed me to use the similarity between two related units of text in order to infer it or interpret it as a causality. In my example, N1 and N2, as you can see here, each one is associated with these concepts, and which they are overlapping text in the same research article, which both talk about success and perception. Because I have coded them in the lens of causality, I interpret them as a strength of the causal connection. If success and perception are frequently and consistently mentioned together, the relationship is stronger than if the two concepts are rarely occur together or mentioned together. Importantly, the T coefficient measure, this type of measure considered word frequencies and overlap as opposed to other type of similarity metrics. And the result, as you can see, building a cognitive map from the research and then weighted all the connection among them, the result is this FCM-based HRO literature that consists of 51 concept and 138 connection. As you can see that each principle has its own group. For example, here, commitment to resilience and difference to expertise. I would like to give a large section of this and show to you that these two principle or two network, you can see that the concepts are not just only connected to each other, but they are connected to the other concept and the other network or other principle. Here in this example, commitment to resilience and difference to expertise. However, the model that I developed, it's general, that can be used by any industry. And it does not actually reflect the specific operational setting of the offshore oil and gas. Accordingly, I have to contextualize the model as I mentioned this before. And I show here in this graph, as you can see, here are the 5 principles, and here is the overall objective, which is organizational reliability that I want to leverage in the offshore oil and gas. But working condition and the culture on oil rig is very different from that environment. That's why I need to contextualize it. There is a concern that some of this, for example, what works in different industries in the assume healthcare industry may not really work in the offshore oil and gas. An example of that could be there is a safety intervention called safety huddle that gather people on floor to before starting the shift. This found to be really work well in the healthcare, but it may not really work well in the offshore oil and gas. Therefore, I came to a list of intervention from the literature of both HighReliability Organization and also the literature on offshore oil and gas. And this is how, by the industry expert, they will be taking this intervention and connected to the driver concept of the model. And then we will find through their opinion, what is the impact or behavior of the 5 principles based on their specific opinion. So how did I do that? How did I contextualize? It was around about 2 stages. The first one was a pilot study that I tested the model that I built, and also the contextualization procedure, if it works well, and it's really worked well. And then after that, I expanded the research through the online survey, which is taking the workshop process and develop more scalable process. And the survey, the good thing about the survey, it's allowed me to collect data on agreement and disagreement between the participant. So here is an example of the intervention of the survey, how the participant intervene into the model. In this example, I defined safety huddle as an intervention. It's given to the expert as defined intervention, so they read it, and I give them a list of concepts through the survey. One of the concepts here, model concept, driver concept, is adherence to standard and risk boundaries. So they read the both definition and they assist if there is really a relationship between the intervention and the suggested driver concept. If there is a relationship, they decide whether the relationship or the causality is increasing or decreasing. And then they actually weight this causality to tell me for how much or for what degree this intervention increasing or decreasing the model concept. So to gain insight from this process, I need to simulate the model based on the industrial input through the survey. To simulate, there are 3 steps has to happen in FCM modeling. First is to activate the concept relating to a specific safety intervention, then run the simulation, and then observe how the 5 HRO principle will change in response to the safety intervention. In this example, there is an intervention called safety stop work authority. This intervention is kind of allowing people in the organization to stop the operation whenever they feel there is unsafe behavior or condition. So, but there's a debate about this specific intervention. The debate is that some organization, they allow their top level manager on the organization to use this kind of intervention. Another organization, everyone involved on the operation floor will be enabled to stop work authorization. And some of the organizations, they really used it well and some not. And some not used it because some of even the people in the front line who are allowed or authorized to use this intervention, they fear to use it of the punishment from their manager. The problem in the offshore oil and gas industry, when I surveyed the expert about this specific intervention, I was surprised that the offshore oil and gas industry, they are trying to do this intervention since 2011. But the problem is still also debatable. People are thinking that allowing top level management with this intervention would dominate people in the lower level. And some people thinking that, managers thinking that giving this authority to people, they could use it in order to hurt or in a malicious way to hurt their manager or to cause problem, because anyone have the panic push button and they will just stop the operation. And then they gave me an insight that this intervention will increase preoccupation with failure, reluctance to simplify, and sensitive to operation, but they negatively impacted both difference to expertise and commitment to resilience. The reason why is because difference to expertise allowing practitioners to migrate the decision making in the emergency time, which means that continue the operation, but lowering the pace of the operation. Until they solve the problem, they return to the normal course of operation. So if you push the button and stop the operation, that means you are not allowing the expert to do that. They will not be able to improvise to be commitment to resilient. That's why it came to be negative. Another example of intervention is one called reporting near misses and safety critical events. This intervention, you can see it leveraged and increased or enhanced the performance of 4 principles, but it did not affect the difference to expertise because there is no connection between this intervention based on the industry expert between this intervention and any concept from the difference to expertise. So you can find that it's improved only for intervention, and there is a difference between the level of degree of change in each one. There is another intervention here is fostering social ties and mutual respect, that making people working as a team. It's kind of team building. And it thought it could be actually leveraging all the behaviors of the people and their culture on the organization, so they will be preoccupied with failures, reluctant to simplify, committed to resilience, difference, they differ to expertise, and of course they will be sensitive to operation. But you can see difference to expertise is not a preoccupation to failure is not really like other intervention, like other, performance of other principles. The reason why, because sometimes when you are working as really very friend to your colleague peers, this friendship, it could turn to be like a kind of complacency. So people thinking that there is somebody is covering their back, so they would not be really preoccupied with failure like others. However, these are 3 examples. I used them when I collected the data from the expert. There could be 10 experts for each intervention, and then I took the average of their inputs and I simulated the model based on the average. So what do I learn from this process so far? That few improve all the interventions of the principle at the same time. Few intervention, I mean, improve all the principle at the same time. Some intervention have intended consequences to reduce some of the HRO principle, and diminishing returning more effort does not lead to bigger improvement. Recommendation in the literature is insufficient and possibly even ineffective. So high reliability is a complex topic and people heavily rely on experience. As a result, it is quite common that participants do not really agree about connection or relationship and also its weight. The result is an uncertainty about the model structure. To overcome this type of challenges, I used a method called EMA simulation, or exploratory modeling and analysis. By that, for example, if I have 10 experts, one of the experts give me a minimum weight like 0.3, and one give me the maximum is 1. So I do not take the average of the weights that given by expert, the 10 expert. What do? I take the minimum value or the minimum input and the maximum input, and I consider this as an interval. And this interval that consists of all these possible values or possible weights for each connection. And then I simulate the model using 100,000 of iteration, and each iteration, the modeling or simulation package will pick one weight randomly. And I will show you in the simulation how this actually works. So in my research, I actually used 100,000 of iteration for each type of simulation, for each run of simulation. This is, again, the same example of stop work authority that I used when I did the simulation through the mean. But this is the radar chart, is when I use the exploratory modeling and analysis simulation, which is basically each connection, again, has 100,000 different weight. So if you can see in this darkened area, first of all, let me show you that this is the outcome of the mean. And these are the darkened area. Every line here is actually representing a weight and its effect on all the 5 principles. The darkened area, as you can see, represent that this random selection, it selected a weight that's very close to each other. So they keep plotting them or drawing them all over to one over the other, or beside it if the weight is close to. So the segment between the participant or the expert, it can be transferred. It's not necessarily in a negative way. It's actually encouraged. For example, in this type of intervention, you can see that there is an enlargement. Give me another possibilities, enlarge the possibilities of the outcome for all these principles. Of course, for preoccupation with failure, because it's almost maximum, so there is no enlargement. And this is actually the new outline for the outcome. It could be another, this one or this one, but I think that there is a possibility to enlarge the outcome of the degree of change in all the performance. However, this is specific stop work authority. You can see commitment to resilience is still negative. So that means the participant or the expert from the offshore oil and gas, they always think that this stop work of certain intervention does not work well in their kind of operations. Here is another example with the social, fostering social ties and mutual respect. You can see there is darkened area here. For example, this is the mean. I just want to emphasize this is the outcome of the simulation based on the mean. And here, for example, preoccupation with failure is enlarged. Difference to expertise is enlarged, or degree of change is increased, but it's on the expenses of this intervention, of this principle. So the general outcome will be this one. So it does not mean that always the disagreement, it could give me all the possible degree of change to be increasing or enlarging. Some of them will be enlarged on the expenses of others. And here is a third example, which is the last example that I brought for this presentation. It's called, and based on intervention called pro-social motivation. What do I mean by this intervention? I'm sure that most of the people have been in an airport, and you will always hear the speaker saying that if you ever heard or watched or observed suspicious items or behavior, you have to report it. So that means you are pro-socially, that you are motivated for the benefit of others. Because when you report something like that, you are benefit not just the self, benefit everyone in the airport, in the society, in the community, in the country, will actually benefit the humanity. So when people on an offshore operations, they are really pro-social and motivated, or turn this to be like a habit, a culture. That means all the people will be preoccupied with failure, all of them will be reluctant to simplify, all of them will be difference to expert when it's needed, will be committed to resilience, will be sensitive to the operation. But of course, their degree of change based on the expert that they think about it, it's not all equal. For example, as you can see here, reluctance to simplify, it's almost like 0.5 degree of change, but 50%. That's because people think that sometimes when you are really pro-social motivated, and also think that everyone pro-social motivated, it will kind of turn you again to be a complacent, and you are just taking what other people telling you. So you are not very well reluctant to simplify. So this is on the EMA simulation. You can see that this is the outcome based on the mean. But there is a surprise that people disagreed or agreed, but they did not increase the or give more possibilities in all the performance of the other of all the principles. So you can see from this line, the increase is very marginal. And there is another thing that people disagreed, or they think that this type of intervention could give me, through the EMA simulation, a decrease of all the principle, or give me this one. It's at the core of the graph, as you can see, so it's negativity. So from that, you can see that experts are different in their opinion. Not all the intervention working well in the offshore oil and gas. So from these three examples, actually what I did, I simulated 13 intervention, but I brought just a 3 example here because the time is really, I don't have much time to explain all of them. So what did I learn so far from this experience? That EMA simulation show how uncertainty about the causal connection translate into uncertainty about the outcome as well. Practitioner or expert can respond to this kind of intervention, this kind of simulation, which is the uncertainty and outcome of EMA simulation. They either accept the uncertainty and implement the intervention. They implement the intervention, but monitor the uncertain outcome to be able to respond when it happened, like an emergency or something. They are redesigning their intervention so that possible undesired outcome will be removed or mitigated. They invest in additional research to solve the uncertainty. However, many of these uncertainties do not much matter. So from this work, what did I learn as a conclusion? It showed me that about the HRO principle, that HRO principles are interdependent and not fully really complementary. Intervention that improves some principle could actually cause other principles to suffer. Decision makers read to carefully craft their strategies, design intervention, test these intervention before they are going to implement it, because any intervention, any program, any scenario, any policy will cost tons of money. So if they test this, like using the simulation and this tool, they will understand what the outcome could be, predict the current behavior and also the future. What is developed here in this research is also tested, is not just developed, a structured method for building FCM model purely from literature. The concept extracted from literature and the connection weight or causality weight is extracted from the literature as well. And also I discovered and I introduced an approach for assigning edge weight, that's I said the T coefficient, for dealing with uncertainties. In practice, this method can be, sorry about that, sorry about, oh. Yeah, contextualizing. In practice, I contextualize the model that's developed based on the specific industry setting of the offshore oil and gas. It could be used in any other organization, any other industry. So that's all I have in my research that I presented. I hope that I defined it well and presented well. And now I am really thanking you and ready for any question from any of the people attending the presentation.
Great. Thank you so much, Dr. Ahmed, about your informative presentation. So for the attendance, so I'm gonna give you a permission. You can unmute yourself if you want, or you can use the chat if you to put your question. So I already gave you the permission. You can unmute yourself, or for people who have any technical difficulty, they can use the chat to put the question.
I think while people are thinking about maybe their questions, I should mention that this work is great, and this work has actually led to a follow-on grant. So what Ahmed is currently working on, maybe you want to say a little bit about what you're currently doing with the model that you've developed and presented today.
Yeah, actually, I forgot to mention this, that this work actually was from my dissertation, which is funded by national academies. We did the first grant with Dr. Antonio Jadder to create a model to strengthen safety culture in the offshore oil and gas. And then the outcome of this grant turned to be another or a new grant, which is really one of the biggest grant that PSU announced, is to bringing the HighReliability organization to the practice, which means that we are using this system model that's developed and turn it into a training platform. So we are also having a lot of work right now ongoing. I'm working on with Dr. Antonio Jadder and other people in the group, the research group, to turn this into a training platform. So we are getting more insight from the expert in the offshore oil and gas to take them and add it to the model, integrating the new data to the existing model, and then build a website that people can use similar to a flight simulator to train themselves and gaining this to understand what's going on in their operation when they try to approach or practice a HighReliability organization.
There is another question also. They're asking, do you think this research can be generalized and applied for other industries than the offshore and oil gas?
Yes, this is actually what I explained it in the presentation. So the model that it has been created with, which I will show you here. That this model is actually general model that every organization could use, because it's built on the theory of HighReliability organization. It's not built on the offshore oil and gas, but the work on the offshore oil and gas or any other industry, it could be through this one, which is the contextualization procedure. The contextualization process that I bring intervention or I select intervention and see how the expert from specific industries think that this intervention could actually impact the model and impact their operation, and the outcome, presented outcome, will showing them this is your input, this is what you did, and this is how you will get when you are practicing this specific intervention if you do that and do this. So yeah, it could be used by any other industry.
Yeah, especially like they're asking about like, especially right now with the COVID, do you think like there is kind of an implementation could happen with the COVID situation?
Yes,
And
exactly. This is also, if Dr. Yedder allow me to say that, we are having a bunch of interviewing people from the offshore oil and gas about their responses, about their resilience to the COVID. It could be used by any other industry, like for example, healthcare. How did they actually react? Were they really resilient to the COVID? Or it could be for any kind, for example, a store, for example, a college, a university. Could showing us how they are resilient to the COVID. What did they do when the COVID hit, when it became pandemic? Did they really stop their classes? Did they continue? So it's showing you their level of resilience through responding to this pandemic, which is a global hit and unexpected hit.
There is another question from Dr. Weber, but I think this is a general question. So by the way, this is a recorded lecture. We're gonna put it also in our YouTube channel. So Dr. Weber, he asking, there's like other people, if they're have an access for this record presentation. Yes, we will send you the link through the YouTube channel. Then not just the BCU student or faculty, they can have an access. So anyone outside of BCU, they can have an access. So that's for your information, guys. Okay. Any other question from the?
So what did you use for a computational platform? Very nice job on the presentation. Did you use Python, R, C, MATLAB?
Thank you, Dr. Anderson, for this question. Yes, so building the, if you can, let me show you that. This map, you can see I used a platform called Mental Modeler. This is how I built the model, and through that, I had to transfer it into adjacency matrix, and the adjacency matrix has been entered into a Python programming package that's exclusively written for this kind of simulation, FCM simulation. Yes, it's a Python programming package.
Mm-hmm. So it translates this diagram into a corresponding Python package that you can then analyze and wrap your simulation around?
It's not actually the diagram. It's not the diagram. The diagram I transferred into an adjacency matrix, as I told in the presentation, that an FCM could be transferred into an adjacency matrix, and the adjacency matrix actually entered the Python package. Yeah.
Okay.
Excel sheet, basically.
And I just see that somebody asked about the Python package. So this thing is up on Git. So this was developed together with a partner who also worked on this project for this purpose.
It's available on the GitHub.
Is there a class that you would recommend that someone take if they want to connect in with this kind of research?
I don't think currently there is a class in the ETM department, which I hope it will be in the future, to teach operational safety. This will be awesome, because right now I have somebody who is working for healthcare, and he's taking his master's in healthcare. So one of the really very, very strongly taught course is HighReliability Organization. So healthcare is a leading industry in this. So they teaching their students and even PhD students how to use HighReliability Organization. What is HighReliability Organization? I hope the ETM department, maybe in the future, will assign or design a course for operational safety, and we could actually teach this class, this research. It will be the core of the research, hopefully. But again, the method as an FCM, it has been taught by Dr. Antonio Jedder in technology marketing and new product development. I mean,
honestly, admittedly on an incredibly limited scale. So in the front end of new product development, we're introducing what FCMs are and do some basic operations, but we do not have a modeling class that would connect to any of the tools.
And also, I remember that you, Professor, gave some also a presentation about it in research method class, front end, yeah.
Yeah, and there are some tutorials on my website, so that's a start.
Yeah. Okay, great.
Okay, any other question from the student, participant? If not, like, we might end it early a little bit, but thank you, Ahmed, for your informative presentation. I really appreciate your this presentation, coming back to our seminar and give a presentation. So with that, I think we will end this record.
Thank you so much, Maulu. Thank you so much, Dr. Jadar and Dr. Anderson, for allowing me. It's a great honor to present this research in the ETM Distinguished Speaker Series. Thank you so much.
Great. Thank you.